Hi, welcome back. This screencast is the second part on quantum numbers. So you'll recall the last time we looked at quantum numbers, we identified the principal quantum number as the energy level or the row on the periodic table. So we had our rows numbered 1 through 7, and so it was just our row number if we were in this first section of the periodic table or if we were over here in this section of the periodic table. In the middle section we took our row number -1, and in this section down here at the bottom we took our row number -2. The second quantum number was called the orbital quantum number, and that described the shape of the orbital, and it was identified by the section on the periodic table. So these first two columns are where the s orbital is, and we designated that with the number 0. Over here, these last 6 columns, this is the p orbital and is represented by the number 1. In the middle, between those two, is where we find the d orbital, which is given the number designation of 2. And these bottom two rows, the actinides and the lanthanides, this is where we find the f orbital, and it was designated with the quantum number 3. So that was how we figured out our first two quantum numbers. So let's go ahead and look at how we identify our last two quantum numbers. So our third quantum number is called the magnetic quantum number, and it is given the letter designation M, and it uses the second quantum number to describe the electron's orientation in space. So by this we mean like which way is the orbital pointing? Is it up and down? Is it side to side? Is it in and out? Remember that the atom is three-dimensional, so it's not a flat object, it's a three-dimensional object. So we have dimension on the x-axis, the y-axis, and the z-axis that goes in and out. We use numbers for our magnetic quantum number to count through a range, and we repeat this. We do it twice. Our range goes from a negative value to a positive value, and it includes 0. So for example, if we looked at our periodic table, the top row on the P section of the periodic table, we have boron, carbon, nitrogen, oxygen, fluorine, and neon. Those quantum numbers for those elements are -1, 0, 1, -1, 0, 1. So our range is to go from -1 to +1. We include the 0 in that range, and then once we've counted through the range once, we repeat it, again going from -1 to +1. So that's what we mean by a range. On your periodic table, you see that here in our P section, okay, where we have -1, 0, 1, -1, 0, 1. So you want to write these values in. Typically what I would do is actually write them at the top of the periodic table. So what you want to do is you want to take your section of the periodic table and divide it in half and figure out what your range would be. So over here for our s orbital section is going to be 0 and 0. In our d orbital section, it will go from -2, -1, 0, 1, 2, and then we'll repeat that, -2, -1, 0, 1, 2. And then down here in the F section, our range is from -3 to +3. So we'll have -3, -2, -1, 0, 1, 2, 3, and we repeat -3, -2, -1, 0, 1, 2, 3. You may want to pause the video at this time and jot those notes down. Our fourth quantum number is the spin quantum number, which is given the letter designation S, and it describes the direction of the electron's spin. So we have two choices here. It can either be -1/2 or +1/2. So if we return to our periodic table, the first time that we go through our range, our spin is going to be a +1/2. And then the second time we go through our range, it will be a -1/2. So just split your range in half. The first time through, +1/2. The second time through, those elements will be -1/2. So the one rule we want to talk about with quantum numbers is called the Pauli exclusion principle. We did talk about this at the beginning of these notes on quantum number when we said that no two elements will have an identical quantum number. Each element has its own unique quantum number. That's the Pauli exclusion principle. It states that no two elements may have the same set of quantum numbers. So each element is unique. So let's say, for example, you're given a quantum number and you're asked to find the element. Okay, the first thing you want to do is look at the first two numbers. Remember, the first number tells you the row number, and the second number tells you which area of the periodic table you're looking at because it's the orbital shape. So what I do is I go straight to my orbital shape. If it's a 0, I know I'm looking in the first two columns because that's where the s orbital is. If I'm looking at a 1, then I know I'm in the p orbital, a 2, I'm in the d orbital, a 3, I'm in the f orbital. So that gets me the general location on the periodic table. Then I look at my row number, and I want to remember to add 1 or 2 depending on the section that we're working on. So let's go back to our periodic table here. If I have a 3, I know I'm down here in my F section. I know I've got an element that's down here if my second quantum number is a 3. If I'm given my first quantum number, my row number is a 5, I want to remember that to get my first quantum number, I took my row number minus 2 down here. So if my first quantum number is a 5, I now have to add 2 back to it to figure out what row I'm in. I'm actually in row number 7. So I'm down here in the very bottom row. Okay, likewise, if I'm up here in this middle section of the periodic table, if my orbital number, if my second number is a 2, and my principal quantum number is a 5, okay, that I have to remember when I got that 5, it was my row number minus 1 that gave me a 5. So I'm actually looking in row number 6. So keep that in mind when you're looking at a quantum number. Okay, so remember to add 1 or 2 depending on the section, and then count over the range either the first or second time depending on the value of the spin, if it's positive or negative 1/2 value. So what I'd like you to do is practice. So for the first 4 samples here, I would like for you to write out the full 4-number quantum number set, and for the remaining 6, I would like you to try to identify the element based on the quantum number that's given. So pause the video at this time, jot down all of these questions, and then either write out the full 4-number quantum number or identify the element symbol based on the quantum number that you're provided. So here are your answers. Hopefully you got them correct. If you didn't get them correct, make sure you're trying to go back and figure out where you went wrong. Jot down any questions that you have and ask Mrs. Benke in class. We will be creating a periodic table that's color-coded for quantum numbers in class together. So keep your notes with you and have them handy to use when we're creating that periodic table in class.